Hey, good morning. So, yesterday was a tough day, but they did some work on my computer last night. I apologize that we had so many parts to that video yesterday. And it was a tough lesson yesterday. So, I want to kind of congratulate you on making it through the day. Hopefully, today will go better. They loaded some software and did some things to my computer that hopefully will help, that we're not going to be pausing here today. All right, so if you'll get these warm ups out of the way. I don't have them on the next page, so if you'll just do them real quick and then pause your video and then come back, that should work really well. All right, welcome back. If we have two choices here. Relation or function is a set of ordered pairs where each number, the domain, is matched to one or more numbers in the range. So each one is matched. So that would be like our mapping bubble where we had 1, 2, 3. Each one, we can match it with more than one number over here. So this would be what we call a relation, not a function, because if we match one domain with more than one number over there, then it's not a function, so we call it a relation. Okay, sometimes I'll draw a little diagram there to help me understand. All right, so here we go. Ordered pairs here, they want us to do the coordinates here. So here's point A over here. So I'm getting 3, 4. Make sure you put parentheses and a comma in between them. It's a coordinate. This one looks like a -3, 4. Point C is down here, so that's a -3 maybe. And now we just have to plug that 4 in for the x. So I hope you said 2 times 4 is 8, plus 3 is 11. So a couple things while we're on this page that I want to talk about, though. This is 4 quadrants in our graph. And so up here, we call this quadrant 1, if you remember this from junior high days. This is quadrant 2. We use Roman numerals. This is quadrant 3. And this is quadrant 4. So when we're talking about which quadrant it's in, we'd say, A is in quadrant 1, B is in quadrant 2, etc. Another thing kind of to notice is all the numbers that would be graphing quadrant 1, when we have a coordinate over there, it would be a positive and a positive. So that means we're going to the right, which is a positive, and up, which is a positive. So over here, if I see the coordinate that's positive, positive, I know this one's in quadrant 1 because both of my numbers in there are positive. Here in quadrant 2, I would start in the middle and go left, so my first number is going to be a negative, and then my second number has to be a positive. So we see that over here on part B. So we can kind of start predicting from our coordinates where our dots should lie if they gave us the coordinates and said plot these points. Down here in quadrant 3, I'd go left and down, so all numbers in this quadrant are going to be a negative, negative. And our last quadrant, if I go to the right, which would be a positive, but then I would go down as a negative. So sometimes this is really helpful in deciding if I see a coordinate of which quadrant it's going to go in. Okay, so I think this is on our quiz that was made for yesterday. So quadrant 1, 2, 3, 4 goes counterclockwise, starting with the right-hand one. Okay, all right. So today we're graphing functions by using an equation and a function table. This is the biggie today. We're going to have a little bit of a different of domain and range, how to record them. And so pay particular attention to that, okay? I thought I deleted these slides. It's okay to still have them here. All they're talking about is a linear equation. It's just a line. We're going to talk more about that. But since it's here, since all these have an x here and no exponent, I know every single one of these is going to be a linear line. It's going to be a straight line. Sometimes they can be going up. Sometimes it will be called a negative slope. They'll be going down. All right. There it is, the linear function. Maybe you remember this from junior high, y equals mx plus b. One of the students yesterday shouted out, "Oh, that's y equals mx plus b form." Yeah, right. We know it's a linear line. It's a straight line. Okay. And like we talked about yesterday, f of x is the same thing as a y. Okay, so don't let the f of x kind of freak you out a little bit. I wish they would have used f of x on all these today, but here's an equation and they want to graph this equation by using the tables. And this is the way you did it mostly in middle school or junior high. I wish they would have said f of x here equals 2x plus 5, because again, these are functions. That's function notation, and I use the f of x. Same thing, okay? Now, going back to last year and the year before, this is how you do a table. This takes the most amount of time. And so we'll talk in the next couple of weeks about how we can graph a lot faster than this, okay? And use some of the graphing information to get some answers quickly. But right now, we all should be aware of this, that we can just make a table. Now, if they don't give us a domain here, they would on some problems. On today's worksheet, they'll say use these numbers. If they don't give us a domain, then we get to make up our own. Most of the time, we will use these numbers: -2, -1, 0, 1, and 2. We use a couple negatives and then a couple positives. Now, I'm kind of hoping that these are a little bit of mental math problems. If you need to write it to the side, that's okay. You can write it to the side. But what we're going to do is we're going to put -2 in for the x. So I'll do 1 down here, and then we'll work on mental math. So we got y equals 2 times a -2 plus 5. -2 times 2 is a -4 plus 5. That'd be a 1. So you put in a -2, and I got out a 1, which is giving me this coordinate of -2, 1. All right, now I'm hoping that we start using a little bit of mental math here. So I'm going to put -1 in here. So -1 times 2 is a -2. -2 plus 5. So if you need to, you can kind of write a little bit there. I get out a 3. So some kids are still struggling with this whole negatives times a positive, what kind of an answer I get. We really got to kind of work that out, that maybe we can do some of these mentally. I like using the number 0 because 0 times anything is 0, so 0 plus 5 is 5. Okay, let's put in a 1. If I put in a 1, I got 2 times 1 plus 5. 2 times 1 is 2. 2 plus 5 is 7. So I got 1, 7. I forgot to write my coordinate on the last one. Now, as I look at my graph over here, I'm seeing I don't have a 7 on my graph. So I'm going to use a different number, but let's see what we have so far. Let's graph what we have so far. Sometimes we have to modify these numbers. So I have -2, 1. That's going to be right there. I have -1, 3. I have 0, 5. And my next one's 1, 7, which is off the graph. Well, I'm going to use a different number there. I'm not going to erase my work for 1, 7, but it's off my graph. So what would be another good number? It looks like my graph is heading down this way. So I'm going to put in a -3. And let's try 2 times -3 plus 5. I got -6 plus 5, which is a -1. So I put in a -3, got out a -1. So -3, -1. Now I know it should be a straight line, and this is my first time using the tools. Let's see if I can figure out how to draw a straight line. Let's see where my ruler is here. Now, let's see if I can draw a line. Aha. Now, because they didn't give me a domain here, let's see if I can draw a straight line here. This is going to be kind of interesting. It's pathetic, huh? All right, so let's try one more time. I think that was under shapes. I think if I do this, that's pretty close. I'll get better at it. Anyhow, and I should have a line. I want to try one more time because I'm not happy with that. Let's see if I can get rid of that. I'm getting it kind of figured out here. I want a line with 2 lines on both ends on this one because this line really does extend in both directions. Let's see how this goes. Hey, that's pretty good. All right. So because they didn't give me a domain, I'm going to connect the lines because this would be a line that is a continuous line that goes both directions forever. Okay. Again, if they gave me a domain up here, then they would be individual dots on my graph. Okay. They didn't give me it here. I think I deleted this one. I'm not sure why these are here. This is not on your practice sheet, so just ignore that one. Let's go down to this one. This is an x squared, y equals x squared. This one you might want to write the rules. Let's try the -2 again. -1, 0, 1, 2. All right, let's see what kind of graph this has. So if I put in -2, I have -2 squared. -2 times -2 is a positive 4. So I got -2, 4 is my coordinate. Again, I'm hoping that we can do some of these simple ones. -1 times -1 is 1. 0 times 0 is still 0. 1 times 1 is 1. 2 times 2 is 4. So we're going to start to see some. This is called the quadratic equation. We're going to talk about the shapes graphs make here in a little bit. And I got 2, 4. Let's graph these guys. 2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Now, I doubt that you got the quadratic equations in junior high. So you're just going to have to work with me on this one for a little bit, and then we'll take some notes here a little bit later on what types of graphs based on my x's there. So on this one, what we're going to do, quadratics always make a U shape. So we kind of get 5 dots all the time, and then we make it into a U. It's a minimum of 5 coordinates or 5 points to make a graph for quadratic equations. It's quadratic, and I know that because there's a 2 right here for my exponent. Okay, so I know as soon as I see an x squared, it's going to make a U shape. All right. See, this one has an x squared, so I know this is going to make a U shape. We've got a little bit more information here, though. We want to add 1 to these, but we're still going to use those same numbers. -2, -1, 0, 1, 2. I'm excited. My computer's kind of hanging in there. All right. So if I have -2, and I'm just going to do the first one, squared plus 1, well, -2 times -2 is a positive 4. 4 plus 1 is 5. So again, sometimes we can use mental math here to solve these. -1 times -1 is a positive 1. Plus 1 is 2. So I got -1, 2. Okay. 0 times 0 is easy. That's 0. 0 plus 1 is 1. So I put in a 0 and I got out a 1. 1 times 1 is 1. 1 plus 1 is 2. I get a 1, 2. 2 times 2 is 4. 4 plus 1 is 5. Let's graph it. And again, since they didn't give us the domain, we're going to graph it. Yesterday, someone asked me, well, how do I know if I connect the dots or not? Because on their paper yesterday, they connected all the dots and had some really weird patterns. Again, if they don't give us a domain, they make us pick them, then most of the time we connect all the dots. If they give us a domain or say these specific numbers, then they're individual dots. If they give a domain with just certain numbers. Now, I apologize for your paper here, so you might want to use my graphs here because when I was doing the practice sheet and looking at it closely, it's like, man, how do you match that graph up? The numbers are kind of tiny. A couple things on my graph over here also you need to notice that not always are we counting by ones. If you look at my graph over here, 4 is right here. So that means we're looking like we're counting by 2s. Here's my function. I know it's in function notation. And they did all the math for us. That was very nice of them. They put in a -3. -3 divided by 3 is a -1. -1 plus 4 is 3. They put in a 0. Now notice something else here. They didn't use the counting numbers -2, negative. They used numbers that were easily divisible by 3 to make their math easy. So that's something to think about as we are picking our numbers as well, is if they ever give us a fraction like that, pick numbers that make your math easy. Look down here. Down here, they picked the numbers and they said, let's put in a -4. Well, they used 4 because 4 is easily divisible by 2. So negative divided by negative is a positive. 4 divided by 2 is 2. 2 plus 2 is 4. So sometimes we can also do that if they're letting us pick the numbers. Okay, so what we have to do is we have to match the graphs up. I like to look at nice simple ones. I'm looking for a graph over there that has a dot or the line crosses at 0, 4. So if I look at the first one, 0, 4 is right there. My graph doesn't work on that one. This one is a 0, 2. Down here, though, I do see a 0, 4. So I'm thinking this graph might be graph 3. Let's try another one, though. I want to pick a nice number that's a nice solid one because they're counting by 2s. So if I go over to 6, 2, 4, 6, and I go up 2, 4, 6, I also see it. So this is a graph 3. All right, next one. Again, I want to focus on the easy ones. I'm looking for a graph that has a line at 0, -1. There's 0, -1 would be like right in here. This one's kind of looking like it might be there. They're counting by 2s, and it's a pretty tight graph. So let's pick a different number that's on there. They said 1, 4. So they're counting by 2s. So if I come up 1, that's looking pretty promising. Let's try -1. Does it end up down at a -6? 2, 4, 6. I think I like that one. So this one is a graph 1. All right, so it's nice they did all the math for us. All right, next one, I'm pretty sure it's probably graph 2 since we haven't done this one yet. So I'm looking at the nice simple number right off the bat, 0, 2. 0, 2, I like that dot. Look over here, I'm going to pick another one. If I go to the right, my x value is 4. My y value is 0. Remember we said f of x is the same as y? Okay. So, I like that one. Graph 2. All right. And here's the ones that you can try. Now we got a little bit of a problem. Well, maybe not. So, you try matching them up. See what you get. I don't know what this big 0 is here for. That's kind of a weird graph there. What's that O doing in there? Anyhow, 0, 1. This one looks pretty promising for graph 1. If I went, they're counting by 2, so if I went over to 3, 2. I don't like that one. Let's go down to this one. This one's 0, 1. See how they're both 0, 1? All right, so we have to pick a different number. How about 1, 4? 1 would be there. 4, I don't like that one. Let's go back up to this one. Maybe I boo-booed. They're counting by 2s. 1, 4. Oh, I'm down here on this graph now, ain't I? Confusing myself. So I'm thinking this one looks pretty good. If I went to the left, -2, does that go down to about -5 where my graph is? 2, 4, 5. Yeah, I like that one. So I'm thinking this one's graph 1. Let's go over here and see if this one's graph 2. 6 is right here. 2, 4, 6. Does it end up on 3? There's 2. There would be 3 halfway in between. Yeah, so I like this one as graph 2. All right. Okay, love it when they do the work for me. All right. Now, here's some notes that I really want you to kind of pay attention to. In junior high, you did a whole lot of graphing like this. These are called linear lines. Linear. So would you do me a favor and write linear here? And that means straight line. And what gives me the clue is I just have an x, no exponents. If I just have an x in the y equals mx plus b form and no exponents, it's going to be a straight line. Now sometimes it's a positive slope, we call it, when the line is going up from left to right, and sometimes it's a negative slope, but it's not a very good line. Negative slope going down. Should have done a whole lot of those. Now, these are called absolute value. You solved absolute value equations, but you probably didn't graph them. absolute values, whenever I see these absolute value signs, I know it's going to make a V graph, a very distinct V. Sometimes they open upwards, sometimes they open downwards. Okay, and then this is called a radical sign. Square roots. Radical or square roots. And these guys will make a graph that starts somewhere and they kind of have a curve. Like so. And we'll look at it here in a little bit. Sometimes they go this way and sometimes they go this way. And I have right here, let's see if I can get it up here real quick. Desmos is a very cool little graphing diagram here that we can say, hey, look at this. Let's do that square root one. Where's my radical sign? So if I'm using my mouse here, as you can see, I got to put a y equals square root, what they say, x, and then plus 3. See, and there's my graph over here. Kind of makes a curve up. So we already know graph 1 matches with equation C. All right. Now let's do some more playing here, though, since we're here. One that I want you to add there to your notes is this one, an x squared. Watch what happens when I do a y x squared. Y equals x squared. X squared. And then I'm going to say, let's do a plus 2. Now you see how it makes a U shape right here? All right. So anytime we have this, it's called a quadratic and it makes a U shape. Hey, while we're here, let's do an absolute value. Y equals, and you know what? I'm going to say a negative absolute value. Let's put an X in there. Absolute value plus 3. Now, you see the difference on my graphs over here? It's in green. That's the nice thing about this too. We do graphs in different colors on Desmos and we can compare them. It's a definite V shape, okay? So when I go to graphing and connecting my dots, if I have an x squared, I want to kind of make it into a U shape, okay? If I see an absolute value, then I want to use my ruler and make a very distinct V shape, okay? All right, so these are the 3 types of graphs plus linear that you'll do mostly in algebra this year. So we want to start looking at our equations and start predicting what kind of a graph we're going to have. So let's add that to, let's put equation D down here just for fun, just for our notes. And that would be a quadratic, so that would be something like a y equals x squared or minus x squared, and let's just say plus 3 since that's what they did on all the other ones. This is called quadratic because of the x squared there, okay? And it's always going to make a U shape, not a V. Sometimes they open up, sometimes they open downwards. All right, so that's good enough for right now on the types of graphs that we have. So without doing any work, we could now look at these and say, hey, that's a linear line, so that's graph 2. The next one's an absolute value, so that's graph 3. And the last one is graph 1. We don't have a quadratic, but what you also could do if you're not sure and you can't remember, just put 0 in. If I put 0 into this equation here, my first linear one, 0 plus 3 is 3. So I have a 0, 3 on the first graph, kind of, a 0, 3 on the second one, 0, 3. That didn't really help. So let's pick a different number. Let's pick 4. If I put a 4 in, 4 plus 3 is 7. When I go to 4 on this one, well, 7's way up here, so it's not that graph. If I put 4 in, 2, 4, 6, 7, looking pretty good there. 2, 4, 6, 7, so it still could be either graph 2 or 3. Let's put in a different number. Let's put in a negative 2. Negative 2 plus 3 is 1. Do you agree? So if I went to the left 2, up 1, that still hits that graph, but I went to the left 2 and up 1, that's not that graph. So you still can put numbers into these equations to make 100% sure that you got these graphs correct. Okay? I would prefer that you remember that this is a linear equation. It's going to be a straight line. This is going to be an absolute value, so it's going to look like one of these guys. Square root, it's going to look like this. Quadratic looks like these. All right? Predict what your graph should look like, so when we draw our lines, we know how to draw them. All right, there's a quadratic. Look at that. There's my x squared. And look, our graphs make a U shape, but wait, now one's opening upwards and one's opening downwards. So let's plug in 0. 0 times 0 is 0. 0 times negative 2 is 0. So if I plugged in a 0, I got out a 0. Now that doesn't help me because both graphs have 0, 0. Let's do a different number though. Now, very important here. This 2 only goes to the x. So let's pick a different number. What do you want? Let's pick 2. If I square 2, 2 times 2 is 4. 4 times negative 2 is a negative 8. So I put a 2 in and I got a negative 8. It might be okay since they're counting. So if I went to 2, 2, 4, 6, 8, that's a positive 8. I put in 2 and I got out a negative 8. So I'm pretty sure it's going to be this graph. So if I go to the right 2, 2, 4, 6, 8. I like graph 2. And we'll talk about why they open upwards and sometimes and opens downwards sometimes. Who's controlling that in our equation. All right, but for right now, we're good. All right, now they already graphed this one for us. Sometimes they'll say, make a table, graph this guy. They speeded things up for us. They already graphed it for us because they want us to work on domain and range. Now, we have a little bit of a problem here because so far we've had graphs that started one place, ended another one. But this one starts in one place and goes forever in this direction here. And it's going to forever go up. And so when we do our domains, we remember that domains are x's. It's a continuous line, so I know I'm going to need an inequality sign, but it's not going to be a compound one. So we have to be kind of careful here. Where does my x's really start? They start at 0 right here. And don't they go forever this way? Even though my graph table stops right here, it's still x's no matter how far out I go because of this arrows goes forever. So what we do is we say x is all numbers greater than, it's a solid dot there, so I'm going to put or equal to 0. So if I put in 6, 6 is greater than 0. And there's 6. My graph, I see an x value there for it. Okay? Kind of a little bit weird. All right, let's go to my ranges. My ranges are kind of the same thing. When I go to my ranges and I start looking, my ranges start right here, and they kind of go forever up this way because this line keeps going higher and higher ever so slightly, but it goes up forever. So I want to say my y's start at 1. So I want to say y is all numbers greater than or equal to 1. 4, yep, eventually out here, if I look to the right, 4 would hit it. 6 eventually out there, way out there would hit. So this is how you do a domain and range for a continuous graph. It has some arrows on both ends, or one end anyhow, sorry, not both. All right, this one has arrows on both ends, and this is usually how quadratics work. So how are we going to write the domain and the range for this one? Well, our domain right now is x's. And so my x's, as I look on my x factor here, doesn't this graph really eventually continue forever out that way and then forever out this way? And so even though our graph paper is only so big, the graphs go forever. And so I could be way out here at -9. I could look up and eventually I'd hit my graph. I could be way out here at -187, and eventually if I look straight up, I'd hit my graph, and my graph paper was that big. So on quadratics, what we do is say all real numbers. all real numbers in both directions because, again, this guy keeps getting fatter as we go up the graph. Now our range is a little bit different because range is my y values. I can't say all real numbers because down here at -6, I'm not hitting my graph. I'm not hitting my graph at -4. I do hit my graph right here at -2. So what I want to do is I want to say y is all numbers greater than -2. Starts at -2, and I would hit forever going up because, again, I have arrows on both my ends of my graph there, and it goes up forever. All right, I see my computer is kind of slowly dying here, which makes me really concerned. All right, so here's the U-triads. Do your domain for this one. And my computer is just seriously getting dim here. I'm going to try to wrap this up. All right, do it, and then let's see if we come up with the same answers here. I think x is going to be all numbers greater than or equal to 0. It starts at 0, and it goes forever in this direction here. Okay, my range, they're counting by 2's. So I want to say y is greater than or equal to 1. Looks like it starts at 1 on my y values, and I keep going up. And again, even though it's going up ever so slightly, this arrow goes forever that direction. Okay? I don't know why. I can hardly see my screen here. Kind of curious of what it looks like on your side. All right, here's my quadratics. Quadratics, you're going to get into the habit of just saying, hey, you know what? I know that graph opens up wide, so it's always all real numbers. Okay. My range, though, is not all real numbers because, again, I don't hit the graph down here. Where do I start hitting the graph? I start hitting the graph right here at 1. Looks like they're counting by 2's. So I want to say y is all numbers greater than or equal to, because it's a solid line, to 1. All right. We're almost at the end here, so I'm hoping we hang in there. Here's our last one, word problem. The football team raises money by washing cars. They charge $5 per car, and they spend a total of $4 on soap. So I want to circle 2 things that are important so far. The table shows the money they raise. Make a graph and use it to find the amount they raised by washing 7 cars. Write the rule in function notation. There's a rule in function notation, so that means when they write it, I don't want to write a y, I want to write a f of x. Okay? All right. So they did the math for us, but they forgot to write the equation. So let's just graph it real quick. 0, -4. Let's talk about that. If they watch 0 cars, why would they be a -4 amount of money they raised? Because that's a big clue on for writing our equation. Right. We spent $4 on soap. So if I watch 0 cars, I'm going to have a -$4 there because I spent $4 on soap. Now let's continue on. 1, 1, 2, 6, 2, 6 is right there. 3, 11. Now you see I'm getting off my graph paper. I can kind of guesstimate probably where 11 would probably be right there. And man, I really can't see my paper here. But this would be where you would need a ruler. And I think I was under shapes. Yeah. So let's see if I can draw my line here. It would look something like that. Now, they did give me some numbers here. And now that I'm thinking about it, common sense would say you can't wash a part of a car. So it's either 1 car, 2 cars, or 3 cars. So I want to erase that line because that line would not make sense on my graph. Now, we have to go and write an equation for this guy in function notation. And then we also have to say how much money they raised by washing 7 cars. Well, it'd be really hard to tell because our graph paper doesn't go up that high. So we want to use our equation. Now, if we wash 0 cars, that means we are $4 in the hole. But they said if we washed 1 car, we made $1. But now back up here, if we get $5 per car, wouldn't we say however many cars, so let's pretend we did one, wouldn't we take 1 times 5 to get the $5? We washed one car, he pays me $5. I paid for the soap, which is a -4, and we made $1. So I'm thinking this is my equation, except for I have to put an x in here because that's going to keep changing. So very simple equation right there to write. So there's my equation, but now since 7 isn't on my graph, I'm just going to plug 7 into my equation to tell how much I would make. So I'd have 35 minus 4, which is 31. Answer the question. They would raise $31 if they washed 7 cars. Use the numbers. So if you just said they made $31, well, the person that's reading your answer wouldn't know, okay, so how many cars did they wash? So if you write it very clearly, like we should, you need to be having both numbers, just like we said. They'd raise $31 if they washed 7 cars. Or you could say if they washed 7 cars, they would have made $31. Something along those lines where you're very clear. Also, think about your graph over here making sense. Would we use a continuous line? No, because either you washed 1 car or you washed 2 cars. So that's why I retracted my line off of that. It would not make sense on my graph. All right. I think I had another one here, but I know it's getting kind of long. So let's talk about your practice sheet. On your practice sheet today, see how they gave you the domains here? So make a table here. Put -1. These are my x values, 0, etc. And on your graph over here, this is going to be a discrete graph because they gave me domains to use, okay? Now down here on problem number 2, that's a quadratic. So in my head, what should we be thinking? What kind of a graph is that going to make if I have an x squared? It's going to make a U shape, right? Or it should make a U shape going upside down. So when I graph over here, it should be a U shape. But you see how they didn't give me any domains? So you need to pick some numbers, just like we did on our study guide today, okay? And one more thing I want to talk about. Here's a word problem that they wrote the equation for us about talking about how far a fish can swim in a certain amount of time. And they gave us the equation, so that's kind of nice. But look, over there on my graph, it's all in quadrant 1. So why wouldn't I, when I'm picking numbers, why would it not be good for me to pick -2 as one of the numbers to choose? Right. -2 isn't on my graph over there. So when I pick numbers, I want to pick numbers. 0 is always a good one to start with. If I plug in 0, 0 times 0.5 is 0. So my coordinate would be 0, 0. But now I'm timesing it by 0.5. If I put a 1 in, 1 times 0.5 is 0.5, and it's really hard to graph that. So I would do numbers that are kind of like even numbers, like 2. 2 times 0.5 would be a 1. So when they're letting us pick our numbers, pick numbers that are nice and easy to do. The next one I would probably pick is 4. What's half of 4? 2. And so when they're letting us pick numbers, again, make your life simple, okay? All right. And you know what? They get down here to 3.5. And so I have to think about, would I connect the dots on this? Can we have on time, can we have a 1 point something hours? Sure we can. So when I'm all done, I want to take my ruler and I'm going to draw a very nice straight line here with the ruler. Now it's going to be really hard. They said estimate 3.5. I can already estimate here. 3.5 would be like right about here. So it's just a little under 2. So if I really wanted an exact answer though, couldn't I pump this baby right into my equation and say 3.5 times 0.5? Sure I could. Okay, it's going to be a little bit less than 2, whatever my answer is, because I can confirm that on my graph over there. And then don't forget, you need to write it in words here, your answer. All right? All right, so you only have 6 math problems today. All right, 3 on this side, 3 on this side. Pick numbers that are easily divisible by 4 on this problem here. Okay, don't pick 1. I guess you could. You're just making your life a little bit more complicated for yourself. All right. Well, it looks like we made it through the video. Hip, hip, hooray. Hey, I also put these because some kids are saying, yeah, Fisher, I'm not getting it the way you're explaining. So I found these that you can copy and paste these guys and maybe go to one of these websites to get some more help. All right. All right. Well, have a good day. Oh, I know. The assignment sheet from yesterday. No, the one for today. I'm going to put the answer sheet on the Google form. And so I'll tell you, correct your own paper, and I'll show how many points the graph is worth, how much the answer is worth, and out of how many. And so on the Google sheet, when you turn it in, it's going to say, okay, you graded your own paper. How many points did you get out of, I don't know, let's say 20. Okay, so you're just going to put one number in your score. You're going to self-grade it because now there's too many things for me to kind of put in on a Google sheet. There's more than one answer. Does that make sense? I hope so. All right, well, have a good day, and tomorrow we have a quiz, so make sure you know how to do domains and ranges, mapping diagrams. All right, we'll talk to you tomorrow.